All right, today we're trying to sort out the difference between specific heat, which we see here, heat of fusion here, and heat of vaporization. And we will be taking one problem at a time as an example just to see how these problems are supposed to be worked. First of all, I have frequently talked about when we're dealing with specific heat problems, what's going to be on top. When I say what's going to be on top, that is going to be determined by whatever the find is. So when I have joules over grams degrees centigrade or grams degrees centigrade over joules, that's all going to be determined right here by the find. So let's go ahead and put the arrow down here to represent what our first fraction is going to wind up being. So with this problem, it's a specific heat, and our first job is to figure out, do we have a solid, liquid, or gas that we're dealing with? Class? Okay, there's enough of you that are not sure. Let's look at this chart. Yeah, now hold on. Just take it and understand how this guy works. Everything between 100 and 0 is going to be in the liquid state. Everything below 0 and up to 0, if it's all solid, will be solids, of course. And this is our trip across, and this is what heat of fusion is for. It is to change us from the solid state to the liquid state. And by the time we get to right here, we are in the liquid state. When we're right here, we're totally in the solid state, and anywhere in between we have solid and liquid. We call that ice and water, right? That's what you have in a typical ice chest, trying to keep the soft drinks cold. Okay, and then we look for the temperature in this guy, and what range is he in? Solid, liquid, or gas? Between 5 and 55, we are what? Liquid, sure. Okay, so we're going to be using the specific heat of what? Liquid, right? 4.18. Okay, so this is our specific heat. Now, looking at the find, what has to be on top? Okay, we got to have the joules there, right? So joules are going to stay with the 4.18. And then we're going to go ahead and make this guy into a fraction. And now, what are we going to put on the bottom of that fraction? Grams, good. And degrees centigrade, of course. Okay, those guys have to stay together. Don't separate them. Okay, they are always going to be 1. Okay, I just hooked them together, and now you see they travel together. Just like these guys up here always have to travel together. So if I'm turning this fraction upside down, when I put the joules on the bottom, the 4.18 goes with it. But in this case, 4.18 is on the top because why? We're looking for joules. Good. Okay. Now let's go ahead and let's do our other fractions, which are going to be based on these givens. All right? These two guys. So I'm going to leave this right here as our first fraction. And now let's go to our givens. What's going to be in the, what are we going to do with grams? Top or bottom? Top. Okay, now you see the top and bottom is not in relationship to the find, is it? Yeah. Has nothing to do with the find, no. Has everything to do with where that unit of measure is that we're adding. Now, the unit of measure is grams, so we're going to take our grams and put them on top, so that's going to cancel the grams out. And on the bottom we have? 1. 1 because this guy is not a ratio. That's important as all get up. Notice with the ratio, you have more than one unit of measure. You have joules and degrees centigrade. Here, the grams are all by themselves. It's just grams. You don't see another unit of measure, so we put the 1 on the bottom, and the 1 on the bottom is coming there because that guy is just making us into a fraction so that we can have our grams on the top. So, yeah. Okay, now what's our next fraction? Okay, is it 50, is it 5, or is it 55?
50.
50. What's 50 mean? How did you get that? Yes. You're going to subtract that 5 up there. This 5 has to be subtracted from the 55 because we're talking about a delta T, a change in temperature. Okay, so yes, it is 50, and let's go ahead and put that right here. 50 degrees centigrade, and that's over 1, and now we cross out our degrees centigrade. We can cross out our grams, and we're good. Now I'm going to ask the people watching this video the same thing I'm going to ask you in class today. I would like you to get all that you see up here, okay, all of this stuff and all of this stuff copied down as givens and finds, and then the complete calculation that you see. So some of you may need to stop the recording if you're watching at home, but for in class we're going to stop as well. All right. If you have everything copied down now, you can go ahead and run your calculation and see if you come up with the same number we did. So as we work this problem, we're just multiplying across the top, and there's no numbers other than 1 on the bottom. So that gives us 773 joules. All right. Let's go on to the next problem. Okay, now our heat of fusion and heat of vaporization are a little bit different. They're actually a little easier. But in these kind of problems, I have to tell you whether you're working on freezing water at 0 degrees centigrade or freezing solid at 0 degrees centigrade, and you're going to be using the heat of fusion because you're at the 0 mark, where on the heat of vaporization we're up at the 100-degree mark. And if you look at your heating curve problems or your heating curve sheet, you'll see that, and you'll see heat of fusion is going to be worked down here, and the heat of fusion is in your little box on the bottom right, and then you have heat of vaporization up here, and that's also down here, boxes D, or I'm sorry, lines D and E. So let's go ahead and work one of those guys and see how they go. Our first fraction, is that going to be a 6.02 kilojoules or 40.6 kilojoules? Oh, I heard dissension in the ranks. Do we have heat of fusion? Okay, heat of fusion, we look down here, that's 6.02 number. Okay. All right. By the way, I'm going to come look around at your stuff. Anybody who has not written this down, I'll just hand you a sentences sheet. It's much nicer for you if you just copy it down.
What's copying?
Huh? All right, here we go. Let's do it. We got the 6.02. Oh, I don't want to do it that way. Let's get the 6.02 up here. And what's the number that goes with 6.02? Or the, I'm sorry, unit of measure? Kilojoules, okay. And from the find, what are we going to have on top in this fraction? Moles. Oh. Okay, so I'm going to make this into a fraction, and when I do that, I've got to take the 6.02 to the bottom, right? Is there anything else that has to go to the bottom? You bet, kilojoules. Kilojoules has to go down, and we've already mentioned that moles will be on the top. Now, what's our first fraction going to look like? First and only, by the way.
83.
Okay, 83 kilojoules. Okay, I know, it's confusing sometimes. So we got 83 kilojoules, top or bottom? 83 on the top. Okay. Oh, gee, this is looking so good. Let's make that look a little better. Okay, 83, and this is kilojoules. And what's on the bottom? 1. Okay, we're done. What's our number? 13 point what? 0.9. Okay. Can we have 13.9?
Yes.
How many sig figs in 83? 2. So how many sig figs should this have? 2. So what's it going to round to?
14.
Yeah, right on. Okay, so this guy will be 14, and what's the unit of measure after we take these guys? And that is moles. Okay, and that is our answer for that second example. Now, let's go ahead and pull this little guy back down, and we'll close this up. And here we go with heat of vaporization. What numbers are we going to use with heat of vaporization? 40.6, good. So the 40.6 comes up, and what goes with that? I don't know. What's the number that goes with 40.6? Kilojoules, yeah. I said number, I meant unit of measure. Okay, and who is going to go on top, kilojoules or moles? Okay, so we can just make this into a fraction with what on the bottom? Moles, yes. All right, now, what are we going to do with that given amount, the 25 moles?
Put it on the top.
Okay, oh, they're doing a call home to all the parents to let them know everybody's okay. Okay, so we got how many moles? 25. Yeah. 25 moles over 1. Good. Okay, so moles go away, and what's our number? 25 times 40.6.
1015.
10 point what?
No, 1015.
1015. So how many sig figs do we have? Here, I'm going to write it 1015. Okay? When we round this, that means we've got to get rid of the 1 and the 5. So is that 0 going to stay 0, or is it going to go to 1? Okay. So this is kilojoules, and when we round it to the right number of sig figs, we have 1,000 kilojoules. Now our sig figs are good. Actually, our sig figs are not good, because now we only have 1 sig fig. Oh, what? How in the world are we going to write this? All right, watch this. 1.0. And now, times 10 to the what? 10 to the 2. Well, the point is here, but it's the decimal point. Okay, you see the decimal point is here, which means it's here in the original number, and that power of 10 has to move that all the way over. So that's why it's a little more than you would think it would be, and that's going to be 10 to the 3rd, and that's kilojoules. And that is our answer with the correct number of sig figs. If we didn't care about the sig figs, that could be our answer, right? So there you go. You got 3 examples to help guide you through your homework tonight.